We're going to do one problem from each section and call it good. So I'm just going to do the first one in each section, I think. Yeah, if you're feeling confident about this, you want to ignore me. Welcome. And I see you work silently if you're going to be working on your own, so that others who are not so confident about it can pay attention and focus. But so basically, we want to make sure that we are confident, comfortable adding, subtracting, multiplying, and dividing with complex numbers. Complex numbers are just things that have i's in them. Just off to the side here, a little quick note. Do you guys remember what I is? The definition of I? I is what? Square root of -1. And sometimes I is defined by giving I squared. What is I squared? I squared is -1. All right, so we'll keep that in mind because we're going to end up with a bunch of I squareds when we start multiplying and dividing these things, and then we'll just turn all those I squareds into -1s. But we don't need to worry about that so much here. This is basically combining like terms. For number one, I'm adding. Those parentheses really aren't necessary. Any real part, that would be anything that's not attached to an I, combine it together. So the 2 and the 6 combine to give us an 8. Any imaginary parts, that would be anything that's attached to an I, multiplying by an I. Combine those together. So -3, +5 gives us a +2i. And that's our final answer. That's it. You guys want me to pause for a second for you to do number 3 and number 5 real quick? Usually we write it like this. Five's a little bit weird. So when they say standard form, they want something plus or minus something times I. So since I had 2 terms with i's in them, my intermediate step might be 5 minus I minus I radical 3. Since I have 2 third terms with i's in them, I took the i's and I factored them out. So technically we would want the I with a factor of -1 minus √3. Another perfectly fine way to write this would be 5 minus 1 plus √3 in the quantity times I. So those would be fine answers for number 5. Any questions on 5? It gets a little weird. Matthew, this is kind of like you were asking a question before about with the quadratic formula, is it okay to leave it in everything in one fraction? So in general, we usually want to split it up so that we've got, in this case, a real part and an imaginary part. And that's hard to do if it's all over one big fraction. So usually we don't want, we've got complex numbers, we don't want them inside of a fraction. Because we want to be able to really quickly isolate what's the real part and what's the imaginary part. Same thing here. Actually, within this, they've also isolated the real part and the irrational part, or the rational part and the irrational part. Just doing a little bit of both. All right, we're going to do numbers 9 together now. Any questions before we move on? I'm going to do 9. I'm not going to give you time to do it 11 and 13 this time around. So bear with me. Make sure you're writing down your original problems always on the homework. We have 2 plus 3i, quantity 2 plus 3i times quantity 2 minus I. And pick your favorite method for multiplying two binomials, FOIL or a little box thing, or however you want to do it. I'm going to go FOIL with this. FOIL is first times first, so first times first is 2 times 2, that's 4. Outside, 2 times negative I would be negative 2i. Insides are positive 3i times 2, so that'd be plus 6i. Last is positive 3i times negative I would be negative 3i squared. Give myself a little reminder what I squared is. That is negative 1, right? So we got negative 3 times negative 1 is really what we're looking at there. My final answer is going to be, let's see, negative 3 times negative 1 is really plus 3. So 4 plus 3, that's 7. And then combining those together gives me positive 7 plus 4. I'm about to move on to 17. So you got 17 through 20. You got to do them all, but they're really quick. Before I move on, question on 9.
So when we're like writing out the answer, do you want us to put the 7 before 4i, or does it matter?
So yeah, technically it doesn't matter. Kind of traditionally, when they say standard form is a plus bi, where a and b are real numbers. So usually we want our real part first and then our imaginary part second. And if b, we like we had here, we had 2 things with I in them. In that case, you need to factor the I out so you can turn it into a single thing with a single I. And again, the reason for that is imaginary numbers become super useful in the engineering world. So those of you who end up in electrical or mechanical engineering, you're going to be using imaginary numbers all the time. You'll have these constants that are used to model a bridge or an electrical circuit or something like that. And you'll want to be able to look at it and see what's the imaginary part, what's the real part. Those 2 things are going to do 2 different things to your bridge or to your electrical circuit. All right, number 17 through whatever 20 asks you to just write it as bi, where b is a real number. So what they're looking for here is 4i. right? The negative inside the radical gives you the I, and the square root of 16 is 4. Now, it's possible in this section you might end up with something like root 7i. If you can't simplify it, then just leave it as that root and pull the I out front, okay? So these are going to be pretty quick. About to move on to 33. Yeah, this is the part you don't want to miss. 33, the division of these. Yep, 33, here we go. Wait, did we not do 29? We gotta do 29 first. That'll help us with 33. All right, you definitely don't want to miss 29 either, because it's going to apply directly. This is the main reason we're doing this today. Okay, general review of all complex numbers is a good thing, but the thing that we're going to be using on Thursday that we really need is this idea of complex conjugates. So 29, they give you 2 minus 3i. And they want you to find the product of that and its conjugates, its complex conjugate. What would the complex conjugate of 2 minus 3i be? 2 plus 3i. And it's the same thing, except the imaginary part gets its sign flipped. All right, as long as you're writing it in standard form, the second part gets its sign flipped. And something happens when you multiply a number by its conjugate. If you were to do FOIL, you're going to see that your middle terms cancel out. So I'm going to go ahead and write this out, but we're going to eventually come up with a shortcut for this. So FOIL, so first times first would be 4. Outside times outside would be plus 6i. Inside times inside would be minus 6i. Last times last would be 3i squared. Or it should be minus 3i squared. Reminding myself that that's really negative 3 times I squared is negative 1, so that's really a plus 3. And I keep messing this up. It's not 3, it's a 9. What am I doing, height? Come on. It's a 9. This is kind of the key thing, though. Anytime you multiply it by a conjugate, if you were to do FOIL, you're going to see those middle terms are going to cancel each other out. You're always going to have one version that's going to be plus, one version that's going to be minus. They're going to match each other. They're going to cancel. So you're going to end up with 13 for your final answer. Can I give you guys some notes that are not in the assignment that's going to make your life easier? You guys willing to bear with me for a second? We're going to go a little off script here. Multiplying complex conjugates. There's a shortcut for this. If I take A plus BI and multiply it by A minus BI, my result is always going to end up giving me A squared. The ABI and the negative ABI are going to cancel, and then I'm going to have B squared, negative B squared, and an I squared, but the negative and the negative are going to cancel. It's ultimately going to give you A squared plus B squared. Oh, interestingly, yeah. I wonder if there's relationship there. So try this example. 4 plus 6i times 4 minus 6i. You can go through the whole FOIL process, but there's no need. You're just going to square the 4, 16, square the 6, 36, add them together, and that's your answer. 52. Do 1 plus 2i times 1 minus 2i for me. Show me, you know what this how this works. One plus 2i times 1 minus 2i. Can you do it in your head even? Square the 1, square the 2, and add them together. What are you going to get? 5. Yeah. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. All right, cool trick, right? Hey, I release you from even showing this middle step on this. If you have to do multiply 2 conjugates together, then you can do it in your head. So 25 is pretty easy. Do we have to do all of them from? We did. So that should be pretty quick. Now 27, 28, you got some. Ooh. What the heck? No, we didn't have to do this. Oh, never mind. 32 is a little bit weird. You know what radical 2 squared is. So that should be pretty easy. All right, now we're moving on to 33. This is the part where things get a little bit wacky. Sometimes on these we have to actually do some real work. I know. We're gonna do 33, and then I'm gonna do 33, and then I'm gonna do oh, I don't know, maybe 38. I know you don't have 38, but I kind of want to do something like 37 or 39 without actually doing 37 and 39. Let's do 33. All right, so here's the deal. Remember how we had this rule that we don't put radicals in denominators? Same thing with I. We don't put complex numbers in denominators. We just don't do that. So this would be an inappropriate final answer to any problem you're ever going to turn in this class. It might be right, but it's not in a format that's acceptable for this class. All right, so somehow we need to turn this complex number into. All right, we're running out of time. Let me give you a shortcut. I'm not going to be doing another problem. We're going to multiply by a fancy version of 1. I'm going to multiply by 2 minus 1i. And I'm going to switch this assignment up on you. So don't leave without writing down the new assignment. I'm gonna cut out those wacky ones. Don't leave. I'm gonna take 2 away and add 2, but you'll be happy with it. All right. So check it out. Because I picked the complex conjugate on the bottom, this is easy, right? Square the first thing, square the second thing, add them together. That's 4 plus 1. That's a 5 on the bottom. Agreed? And then on the top, we've got a 2 minus 1i. And then we write it in our final form, which is 2 over 5 minus 1 over 5i. That's our final answer for number 33. So take whatever your denominator is and just multiply it by a fancy version of 1 that's the complex conjugate on the top and bottom. I'm changing your assignment on you. You're welcome. You're going to be happy about this. Only until you get this. Cutting off 37 and 39. We're just going to do 33 to 35. I'm taking 2 away and I'm adding 1. Okay. I'm taking off 1, I'm adding 1. 33 to 35, all. So I took away 37, I'm adding on 34. We don't need to do 37. That's nasty just for the sake of being nasty. So instead of 33 to 37 odd, just do 33 to 35 all. It's the same number of problems. It's a less, I traded a nasty one for a pretty friendly one. Thank you, folks.